Hey guys, and welcome back. My name is MrCaproni, and this is Probability and Statistics. Today we're going to be talking z-scores, and I'm talking everything about them. We're going to discuss what the heck a z-score is, we're going to talk about the formula used to find them, and we're going to talk about some example problems where we can apply that formula to see how this is actually used. Go ahead and stick with me all the way to the end, and you'll see some important facts about z-scores as well. With that said, let's go ahead and dive right in. So let's go ahead and start off by defining what a z-score is. A z-score is how many standard deviations away from the mean a given point in a list of data is. Now that may seem like a lot, so let's break that down. If we have a full list of data, we would first need to find the mean and standard deviation. The mean is just another word for average, so you'd add them all up, divide by how many you got. And the standard deviation we've actually found in another video up above, but it essentially is the average distance from the mean of all of the individual points. So then a z-score comes in. That's if I take any one individual point from that list and see how far away from the mean it is by using that standard deviation we found as a form of measurement. Now, I can look at it here to help you out on a bit of an example. If I'm looking at the ACT scores in America, the national average is a 21 with a standard deviation of about 5. So if I were looking at an individual score of, let's say, a 26, it would have a z-score of 1 because 26 is exactly 5 away from 21, which is the standard deviation. So in other words, I have moved 1 standard deviation away. Likewise, if I got a 31 on the ACT, I would have a z-score of 2 because it is 2 standard deviations above the mean. So where would you actually use this? Well, let me start off by looking at the empirical rule right here. If you did not know, you can use this empirical rule, which I have a whole nother video about up above, and it tells you what percent of the population falls within so many standard deviations. So if I'm looking at an example of something in real life and someone tells me that they're 3 standard deviations above the mean, I actually know what percent of the population will be above or below them based off of that z-score, along with the fact that I can tell you 68% of all people fall within a z-score of -1 to 1. So this kind of helps us measure things in terms of percents of populations and in a lot of probability questions. Another cool thing about z-scores is it allows you to know a lot about something you actually know nothing about. For example, I actually had heart surgery as a young child, and every year I have to go in for an appointment to see how my heart is currently doing. One of the things we discuss in there is the current diameters of the arteries going in and out of my heart. Guess what? I know nothing about that, but I'm able to have a solid conversation with my doctor about it because he talks about it in terms of z-scores. So when he says that my heart artery diameter has a z-score of 3.28, like you see in the diagram right here, that tells me that I'm so far away from the mean of the rest of the population that there is some reason for concern. So even though I know nothing about the actual average centimeter of heart arteries, then I'm able to still discuss it by knowing how I compare to the rest of the population. And this is actually a common thing z-scores are used for as well, is to compare things that normally you wouldn't be able to compare. So when they say never compare apples to oranges, I disagree. Convert it to z-scores, and then we can talk. All right, enough of the chit chat. Let's go ahead and take a look at the formula for a z-score. Now, this is actually fairly easy to do. Whatever value you're looking at, so for example, when I said like the ACT score of a 26 or of a 31, that would be your value. You take whatever value you're looking at, you subtract the mean of the data, and then divide by the standard deviation. And that's going to give you the z-score. So let's go ahead and try this in an example. So if I'm looking back at the ACT scores like we were in the beginning of this video, I can see that the national average is a 21 with a standard deviation of about 5. It's actually lower than that, but let's keep it easy for this example. So if I'm looking at a score of 26, what would that have as a z-score? Well, by using the formula, I would just go ahead and plug in that value of 26 minus the mean of 21 divided by 5, the standard deviation. Now, 26 minus 21 is just 5. So if I do 5 over 5, that's just going to give me an answer of 1. So that means that in this case, a 26 is 1 standard deviation above the average score of a 21. Now, it gets a little bit trickier with the next example, looking at a score of a 10. Because when you plug that in, it's not going to turn out being an even number. And more importantly, it's going to end up being negative. When we work this out, we actually get a negative 2.2. And this tells me two things. Number one, the negative tells me that our score is actually below the average, not above it. So anytime you hear of a negative z-score, that just means that you are below the average, not above it. And the 2.2 tells me that I am 2.2 standard deviations below the mean. So it still tells us a bunch of information, and in fact gives us a bit more with the idea of looking at positive and negative now. Now that last one is working backwards. What if they said you had a z-score of 2? How would you find out what that person's ACT score was? Well, I can go ahead and plug in the original formula again, except this time I'm going to leave the value as x and set it equal to 2. Well, then in that case, I can multiply 5 to both sides to give me x minus 21 equal to 10. And then if I add that 21 back to the other side, then we'll see that x would be a 31, which means if someone tells you they got a z-score of 2 on their ACT, it means that they got a 31 as their actual score. Now let's go ahead and wrap up by looking at some important things about z-scores. First off, a positive z-score means that you are above the mean, where a negative z-score means that you are below it. So the sign does matter here. And don't freak out if you are getting decimals or fractions. A z-score does not have to be a whole number. It can be positive, negative, decimal, fraction, whatever. Remember, we're looking at how many standard deviations away from the mean you are. So you don't have to be exactly 3 away. You could be 3.5 away or 3.2 away. That is all right. Lastly, when you're looking at how rare something is, just know that if you are above 2 standard deviations or below negative 2 standard deviations, you're considered to be pretty unusual because that means you're falling outside of the middle 95% of the population. And likewise, if you're at above 3 or below negative 3 as your z-score, then you're actually considered very rare. It is extremely unusual to fall further than 3 standard deviations away from the middle. So if that's the case and you got a z-score above 3 or below negative 3, we actually label that as being extremely rare or very uncommon of a situation. Feel like you've learned something about z-scores? Good, then go ahead and hit that like button below to let me know I'm doing a good job and to help out my channel. Because at this point, we're ready to wrap up this video. We started off by talking about what a z-score actually is, and then we talked about how you can actually apply that in real life situations. Then we took a look at the formula and used that formula in an actual example problem. After that, we wrapped up with some important things to know about z-scores. And if that was helpful to you at all, like I said, go ahead and hit that like button below. And also, if you want to keep getting videos like this, go ahead and subscribe to my channel because I'm uploading new videos each and every week. Remember, my name is MrCaproni, and this has been Probability and Statistics.